Hi, I'm Jonathan Stevens, and in this tutorial, I'm going to show you how to make a 3D Gaussian splat. If you've never heard what that is, if you know nerfs, it's basically like a nerf. It's a radiance field in that way. I have on my screen a 3D Gaussian splat. It runs in real time, so right now this is at 60 frames per second, and you have this scene very much like you would see a nerf, but in really high quality. It's going to run real time if you have the right hardware. You can move around it interactively, and we're going to show you how to make it. Just to quickly just give you like a 5-second version of what a 3D Gaussian splatting is for radiance fields. Well, it's basically representing the scene as a bunch of little splats. So if I really zoom in on something in here, you'll start to see these kind of like shreds or shards, and those are called splats. And I can take them, I can scale them down, and they get smaller and smaller and start to separate. And they look like these just like diffuse looking shapes. Basically, when you take a bunch of those and overlap them, and they have a Gaussian as a distribution, so think of like a shape, it starts to represent the scene to look like solidness. So here I'm trying to move around. So when you have a bunch of overlapping points, it looks like a solid wall over there. But if I bring it down, there's just, a few splats will make up part of the scene. And in some spots, there's hundreds or thousands. So again, I'm going to show you how to make this from your own data in this tutorial. And we're just going to jump in right into it. And if you have any questions in this, make sure you ask them in the YouTube video, but also I will have the GitHub repo up that I use that as a fork. Make sure you ask questions in the original GitHub repo if you can. So let's jump to it. Okay, for ease, I have forked the main GitHub repo with all the codes for 3D Gaussian splatting, and you'll see that this is forked Windows installation. So this is just for Windows. And if you are running Linux or something else, you're going to have to use the original install. But you need Windows 10 or 11. I did this on 11, worked just fine. And I will have the YouTube video linked in here. And this repo may look a little different by the time you get to it. I just wanted to have this ready for you in a way that we can go through it together in this video. So just at the start, you'll see I have a little bit of notes. And then this is just from the regular GitHub repo. And again, I'll link this in the show notes to go find this repo. But you'll see there's a little overview. So there's like 4 main components to making this. First thing is turn your own images optimized into training the data. So basically, I'm going to take some images or a video, and I'm going to get it ready to turn into a Gaussian splatting scene. The next part is an optimizer, which is instead of preparing, you prepare your images, then you got to train them. So it's like learning what the scene looks like. People think of that as like your data processing. And then the last part, there's actually 2 parts. There's a network viewer and a just real time on your PC viewer. I'm just going to skip over to the last one. We're going to use the visualizer because it's just an exe. You don't have to do any fancy install, and it's a great way for you just to learn what this is. So also, before we get going, you have to have your computer set up. Anytime you do any sort of code build, you need to have this set up ready to go with some pre-installed software. Now, if you've done any nerfs or anything like that, most likely you have some, if not all of these already installed. But I'm going to go through these as quick as I can. I'm not going to install them all because they're already on my computer. I just want to show you what that process looks like. So first thing is, let's go over hardware requirements. You have to have 24 gigs of RAM. I put an asterisk there because there will be some codes I'll have in an advanced guide coming soon, and I'll add it to the GitHub. You can modify your output or your training variables to be able to use like a 3080, like 10 or 12 gigabytes to run this. So this might not be for everyone, but I will, as quick as I can, get that modification in there. And if you actually look in this repo, it's already in there somewhere at the bottom, but it might be a little confusing. So just make sure you have the right hardware. Then you're going to need Git, because you need to pull this code using Git, or you can use the GitHub app. Git's pretty easy, but I put it in here. You're just going to click here, or you can download it. I put a link in there. So here we go. And you're just going to download the Windows and install it as I asked you to. And then you can always open up your command window. So how I did that, if you've never used command, you just go like search your apps, hit CMD, enter, bring up your command prompt. And then here you can always type in git -- version. If you're unsure if you have it, see, I already have it. I already have 2.42.0. So that's an easy way to check if it's there. The next thing you're going to need is Conda. Conda is basically setting up a like mini environment inside your computer with all of the like base code that you need, all the packages installed, and it just puts in a little wrapper that you can always activate at any time. I say use Anaconda. It's a great one to go off of. If you just go to the anaconda.org, again, this is all free. You're going to download it and install it just like normal, like any other thing. Just make sure it's adds everything to path. You're not modifying anything special, and it'll create that. And I have Anaconda running here. Anaconda is great. Their navigator. You can see all your different environments that you've set up in the past. So you can see I already have Gaussian Splatting set up, Nerf Studio, NGP. You can see what's in here. You can update your packages, all of that. Makes things easy for a novice. So I do recommend using that, as well as if I go back here, this Mini Conda, which is a mini version. That's also one. I actually used that one for a long time. I started using Anaconda more recently. So I say jump into Anaconda if you want to get into doing more of this code building, things like that. You also need CUDA Toolkit. They said they tested with 11.8. I have 11.7. If you know you've installed CUDA Toolkit already and you're not sure what version you have, you can type in nvcc -- version, and you will see which version. So you see I have 11.7 in here. Just caveat, don't have 11.6 and don't have 12 plus. And they say that in here. And I do have a link. So if you go here to this link, you just find the one they referenced, 11.8. Go download that one. That's the one I would use. So once you've got that installed, we got to keep going down the list here. You're going to have Windows Studio 2019 or newer. Again, I have a link. You can just go download it. They did theirs in 2019. I always suggest using the ones they have. But if I go to my Visual Studio installer, one thing I want to point out is that you have to make sure you install this with the right like system thing. So if I go to 2019 and modify it, go here, you got to make sure you have this desktop build development with C++ checked on for install. If it's not, check it and it'll add that as an installation. That's what you need to get this up and running. Probably at this point, I recommend restarting your computer because it might not recognize all these things you have. I always notice that's a problem when you're adding all these things. But there you go. Okay, we got 3 more things we need to install to get this running. I know it's a lot, but it should go pretty quickly, and you just pause the video in between. But Colmap. So again, a lot of people have problems with installing Colmap. Since we're using Windows, just go to this link, go down here where it says the top one, Colmap 3.8 Windows CUDA zip. You're going to download that. Here, I'll just go ahead and do it on my own computer. And we're going to unzip the files, and we're going to put it in our on our computer anywhere you want. I put it like in my root C drive, or maybe not root, but like my user folder, and somewhere. And then you got to add it to path. So once this is downloaded, I'll extract it and show you what I mean by adding to path. I think a lot of people, they run into problems with this, and it's actually pretty easy to get Colmap installed. So here you go. It's still downloading. Okay, so now it's done here. I'm just going to extract this all to, sure, I'll put it to my downloads folder. This might take a second, depending on how fast your computer is. Okay, so now I have it downloaded. I'm just going to search for this darn thing. You have this subfolder. So just take this, and I'm going to cut it. I'm going to hit Control-X, or you can right-click cut. I'm just going to paste it in my root folder. This is, for me, it's JONAT, because I call my computer Jonathan. That's my username. So here we are. It's in here. Now I got to add this to path. So if I go to, again, like your search, and you just type in environment, edit system environment variables, and hit environment variables. Now I can go add it to path. So down here, you have your system variables. And what you're doing is you're telling the computer like where to find this program when you use it in command prompt. So if I go to path, I've already added it at one point in here. If I go find it, I believe I have it in a Nerf folder somewhere right here. But all you got to do is hit new, and then go to that folder that you've pasted in here. So you go into here, you have your top, here's your path here, just control copy. And then again, new, paste it in there, hit OK. Now it's added it to path. Now I'm gonna go delete it because I already have it somewhere else and it'll confuse my computer. But that's simple. Now you have that in path. It will know where it is. So let me just delete that. Okay, so now go back to dependencies. So now I have this image magic. This is for like resizing your imagery because it's gonna want to do that. This is optional, but I say do it because things won't break then. You just go to the downloads page, download it and install it. You got to just look for the Windows one. So right here, it'll drop you down and then just get this exe version. And when it's done installing, you can again verify by putting these command prompts in. So again, anytime it says command prompts and puts like 3 in a box, just copy 1 line at a time. So that's going to load up that logo. In fact, I don't even need to do all 3. The second one says, okay, here's the logo. And then this last one will, I think, launch it, but it might not actually work. We'll see. It didn't work for me last time, but I know it's installed because it identified the image for me. I'll see here. Yeah, so it was in my temp folder, so I think I scrubbed it out, but you can just run those through to see if it's running. All right, so last thing we're gonna do is FFmpeg. Again, this one is a little bit confusing. Again, you're just gonna go download, go to the download, pick one of the files. It kind of takes you to the subfolder. You really need the essentials. So you can just get the FFmpeg get essentials and unzip it. And it's the same deal. So you're gonna go unzip it, put your computer, then you can go to your environment variables. And I have mine in my user variables, but you can put it in the whole system path. But again, I have FFmpeg bin. So it looks like I have downloaded it to, hopefully I haven't lost everyone in this video so far. To, okay, JONATH, oh no, it was in my C. FFmpeg folder right here. This was unzipped. And then you have this bin folder. So that's where like the exe lives. Just take this, copy FFmpeg/bin, and then you're going to go new, add it to your path, and save it. So already you've done that. It's right here. Super simple. You can put it in user or system variables. It'll work just fine. And again, you can run that help command to see if FFmpeg's working. All right. So now we've gotten this far. The next thing you need to do is pull the code. Okay, so now I've got all the dependencies installed. Now I need to pull the code off the website. And that's just going to get everything off this GitHub repo. It'll get it from the source directory. So if there's been updates since I forked it, you'll get them. But you're just going to go, and it's called cloning. So I'm going to take this HTTPS one. You don't get that top part, the hash HTTPS. You just grab the second part, control copy, and I'm going to paste it and hit enter. And this shouldn't take too long. It's just going to download everything off the GitHub repository onto your PC, and I'll show you where that ends up living when I'm done. It'll be slightly different for you, just depending on, or the name of your computer. It might look a little different. So now it's done. So you'll notice when I'm in command, so I'm assuming you've not used command a lot, but this first part is the conda environment I'm in. I'm in my base environment. Then this is like the directory I'm working from. So C users JONAT. So that's like my root Jonathan folder. So if I go to my computer, I have, my C drive here, users, and then my user profile folder. And that's where it's going to usually download to. Now you could have changed where that is ahead of time, but it's always good. For me, it's always easy to put it in that user profile folder. So now I can move to that. So if I hit CD, which means change directory, space, I can type in Gaussian Splatting. And if I start typing it and hit tab, it'll auto-complete off of what I've started typing. Now hit enter. And now you'll see I was in this users JONAT folder. Now I've moved into the Gaussian Splatting folder. So if again, I go into here and I go to you'll see I have it listed Gaussian Splatting. So there's all the code that's been pulled. Now it's not installed. You just have the code sitting there. Now it needs to be like built on your computer because it doesn't have like a pre-built installer for you. So we finished this cloning repository. We're moving on to the optimizer where we're going to set that up to get everything ready. So the first thing you're going to do is go to setup and you'll say set. So we're just going to grab one line at a time. You never grab all these lines. Don't use that copy button. So we're just going to, let me make this bigger for all you. So it's going to grab that set distill utilities SDK1. Gonna hit enter. You won't see anything change. That is fine. And then I'm going to go to this conda create file environment. Now this right here is what will build everything, and fingers crossed. And if something doesn't work, I actually suggest closing your command prompt, even restarting your computer and trying again. In fact, I'm going to do that really quick because I think I have not restarted this since I've put all some of my dependencies on here. So here we go. CD, Gaussian Splatting, paste that in there. So we're going to go to conda environment, create. It's going to create off this file that's sitting in the Gaussian Splatting folder. So if I go to that, I'll just show you what it looks like. It says environment.yml. It'll bring up, it's a text file. So it's like the name of the environment, the channels, the dependencies, and it'll run all the installers for you. So let's just hit enter. And this part might take a while, so I'm going to skip to when it's done. I actually have recorded this now twice. The first time it failed to build the first time, and all I did was restart everything and it worked. So I might run into that as well. So I'm just gonna let this run for a second and I'll be back to you when this is done. Okay, so this installed first time for me without any problems. Actually, I only had problems one time when I did this. That was because I had installed some new dependencies. But when you're all done, it'll run through this for a while, but what it'll do is it'll show, let me just make this even bigger for you all to read. It will say, you know, okay, you might have to update your conda, all that, but as long as it's all good, you should be happy. So the first thing I'll say, preparing transactions, verifying transactions, and it'll sit on this like installing pip dependencies for a while. And then as it goes, it'll show processing the different things. It'll say started, finished, done, started, finished, done, started, finished, done. You know if something didn't install correctly, if it said like error, and then it'll list what didn't install correctly. And as much as I'd love for you to say on the video what didn't go wrong, and please do in the comments, you might have a better luck getting this figured out by going to the GitHub repo and asking questions there. However, please put them in this video as well for people to learn, but I might not be able to help you. I'll do my best. So there we go. Once it's installed, we're almost done. Things get real fast from here. Kind of. So we're just gonna take this, minimize it again. And so the first thing we need to do now is take the images from a video or a bunch of just images you've taken and convert it to, you're gonna prepare them for training. So again, if I go back to this thing, we're gonna go is prepare your images. And that's basically like telling the computer where all your images are in 3D space in relationship to each other. And that's what ColMap is used for. So I've already done this on an old project, but I'm going to run it through you how it's done now and might not wait for it all to process and do some fast forwarding. But when you're taking images, take images in the same manner you would take them for a NERF or for 3D modeling. You want to make sure that you are basically walking around objects. So like walk 360, walk slow. You don't want blurriness. You want to do multiple levels of angles. Let me just bring up an example one. I think this is still here. So here's one from a crane. I will make sure I credit the flight pilot here in Jeff Wolf in this and the notes, but this is great. Notice how it's slow. We don't have motion blur. The only thing I don't like about this scene is the smoke hanging out above it. But other than that, you know, things are pretty consistent. This would be a great nerf. This would be a great Gaussian splat. Anything where the scene stays pretty static and you don't have a lot of motion. Now, I would have loved this flight to be at like 3-4 elevations moving up, but that's all you need to do. And if you're doing a room, kind of do the same thing. Just walk around the room in a 360, kind of always focus on the opposite side of the room. So there you go. So now, if I want to take a video like that crane one, I'm actually going to copy this, and you're going to go to your, here. Okay, so I'm going to take this file here and use this as an example. It won't be actually, I think, the nerf that we end up training, but let me just go take it and put it in the Gaussian Splatting folder that I have. So I've Gaussian Splatting. I'm actually going to create, you don't need to do this. You can just put all your projects in one folder, but I'm going to call this data. This is where like my source image data is going to be. You can call it whatever you want. I'm going to call it data. I'm going to go in here, and then I'm just going to, well, I pasted there. I meant to make one more. So a subfolder called crane. And I'm going to put that crane video in there. And then here I need to get images because this system is optimized on photos. So I'm going to go back to my command prompt window here. And the first thing I need to do is I need to change directory or into where this video is. So CD, and then you can just copy this and paste it like so. That's one easy way to do it. But since we're learning here, I'm going to give you a little tip. Oops. You can also go CD and then type in data and then /crane because it knows we're in this Gaussian splatting. So I just got to give it kind of like the path. So that'll also get you there. But now I'm in that crane folder. I can type in FFMPEG, and that's like an image preparation software that we can extract single images from. And then I actually have a script that I will put in the GitHub repo for getting this out, where I'm just going to copy and paste. So you have an I for input. We have our input video. So if I just kind of go back here and delete that video part, I can just take that video and drag it in there, and it'll put the path in. So I don't have to type all that in. And then you can skip over the next part where it says qscale, V1, all that. What you're carrying next is this FPS. And so how many frames per second? So if I go in here, I want this video is 1 minute and 28 seconds. So that's 688 images. Let's say I want to double that. I can put 2, hit enter. And now it's going to start extracting images from that, and it's going to take 2 frames per second. So I will end up with double that. And that's a good way to do it. It's just like take the seconds and figure that out. You can even do fractions. So let's say it's like a 5-minute video. You could do 1-4 for like one video every, or one image every 4 seconds. And then here I have 177 images. That's awesome. So now I need to take these images and I need to start training those. So if I go back to the repo, let's see here, that's in here, back to the repository, and I go further down past interactive viewers, there's a section. I may move this by the time you watch this video, but it'll say processing your own scenes. This is our ColMap loader expects the following dataset structure for the source path location. You can just kind of skip over that, but what you care about is the second part. So this is saying, hey, we don't already have like a folder of data set up. What we need is the location needs to have an input folder with their images in it. So if I go in here, I'm going to hit new folder and just call it input. Like so. I'm going to grab all these images, not the video, just the images, drag them in there. So now what I have is this project folder with an input subfolder. So that's what I care about. And this crane is the location. And then we have our input. So pretty simple. Now I'm going to go back to my command prompt. And we need to activate our Gaussian splatting conda environment we created. So I hit conda, activate Gaussian splatting, enter. And now you'll see it doesn't say base. Yours might say nothing, but now it should say Gaussian splatting at the start. And that means we're in that environment with all the code loaded up, ready to go. And now we can start using the Python scripts and all that. As long as we're in the Gaussian splatting folder with this Gaussian Splatting conduit environment activated, we're good to go. So I'm actually going to go back. So in the Gaussian Splatting, we have a Python script called convert, and that'll convert images into the way we need them to train this data set. So I'm just going to go here, and I actually need to go back a couple levels. So if you go cd ... it takes you back one. So cd ... So now I'm back to Gaussian Splatting. You may not have done that. You may have already been here, but now I know I can use the training Python script, and you're just going to copy and paste what they have. So you're going to take this Python convert pi-s, not the rest of it, just that first part, like so. And then where's that folder we just had? So that was data/crane, like so. That's that crane folder with the input images. Enter, and it'll start running Colmap and get all your images prepared. I'm actually not going to use this data set. I'm going to use a different data set because I've already trained one, because it's a pretty lengthy wait if we're going to do this all from scratch. But that's how you get your images ready. If you already had still images, you could skip the FFMPEG. So this is going to run. This might run for 5 minutes, might run for an hour, depending on how long it is or how many images you have. So I'm just going to close this though, and I'm going to start a new conda prompt. And I'm going to show you what it looks like when it's done using a different scene. So anytime you open this conda prompt, by the way, just make sure you go to conda activate Gaussian _splatting. And then we're going to change directory to Gaussian Splatting. And that's know you're ready to move some code again. So now we're back here. I already ran one on a folder that I have kind of saved away. Let's go here to Gaussian Splatting archive. So I've done a few of these. So for example, the one I showed at the start of this video of myself, let me find that here. When you're done, I had this input and I had these images of myself. It was from a video. And so you can see like just a bunch of overlapping as I go in a circle around myself. And when it's done, it'll look like this, where you'll have this distorted folder, images, input, sparse, stereo, all this stuff. Just, that's great. That is your source folder ready to go to train. So I'm just going to minimize this. So once that's ready to go, we're going to go back up to the optimizer section where we did the setup, and we're going to run the optimizer. So that's going to like get everything ready to go. So Python train -s. So just like the last command, but instead of convert, it's train. So I'm going to paste that in there. And then this data, actually skip this step. So I would have that crane folder ready to go, but I don't. So I'm going to use this J Weatherford one. So I'm going to copy and paste that into my Gaussian Splatting folder. Data here. Okay, so now I have that in here. So I'm gonna turn on that scene. So data, and then J Weatherford, like so. Hit enter. And if all goes well, you typed it all right, it's gonna start training that imagery to the scene that we're gonna real-time view later. So this usually takes a minute for it to start going. Okay, so now it's running. It creates an output folder. It'll start loading all your cameras, and it'll start the training. At this point, this section takes about 45 minutes on my RTX 3090 Ti. So just know that this could take up to an hour on your 3090. Could take less depending on what, there's some variables. But as it's training, it'll say training progress. And so it's going to 30,000 iterations. That's like your 100% bar. But at 7,000, it will save a checkpoint. So it'll be partly trained, which you could actually look at it then, but just let it run until it's done. And when it's done, it'll self-complete all that. And you could do the math. It gives you a prediction. So it says 27 minutes. I've seen it take anywhere from a half hour to 45 minutes on these. So just going to let this, I'm going to fast forward in this video because I don't want to sit here and we're not going to watch this run for that long. But that's what the training process looks like. And then I'll show you what it looks like when it's done as well. So again, I'm going to hit close on here and just reopen my Conda. And just to reinforce it with y'all, every time you close Conda environment, we got to Conda activate Gaussian Splatting, and then CD Gaussian. I'm going to get about that fire tab to complete. So now we're ready to go. But when that's done training, if I go back to my Gaussian Splatting, see in here, you have an output folder. And so there it was training. It gives it an arbitrary name. Just rename it when you're done to whatever your source folder was so you can remember it. But let me find the one I had done that was archived. So if I go Gaussian Splatting, oops, here to my archive, you can see my output scenes. So this is what it looked like. I'm actually going to copy this into the one we have. So you don't need to do this part. I'm just copying the output, so you'll see what it looks like. So at the end, you'll have a file that looks like this at the top. You'll rename it to the same as the source folder, so you're not having to like remember all that. But you'll have this point cloud folder, a camera.json, this arguments file, and then an input POI. So if you don't see all four of those in there, then you know something went wrong, and then you'll see your 7,000 and your 30,000 iterations output. So now your model's trained. Now we get to do the live viewing. So this part's actually pretty quick and easy because I have a binary. So if I go back to my GitHub repo, it's been trained. We have the output data, and we're going to come down to the running the real-time viewer. Actually, that's what we're going to run. You can read the directions in here, but actually we need to download it first, which I believe is here, the pre-built Windows binaries. We built the pre-built binaries for Windows here. I'm just going to download that. Opening tab. Forewarning, there's a bunch of Linux stuff in here I'm going to delete out as well, so hopefully you don't have to work your way through all that. So once this downloads, it downloads this viewers.zip folder. Let me just find it in my downloads. You'll have this viewers file. See, I've done it multiple times, so let me just find it in a subfolder. So you end up with this viewers. We're just going to extract this all. Extract. Okay, back to downloads. Here it is, this viewers folder. I'm just going to take this folder, all of it, cut it. Now I'm going to go to my Gaussian Splatting folder. And it's going to paste it in here. So now I have a viewers folder. So that's viewers is got in this bin folder. You have an exe for viewing everything. This Gaussian viewer app. And so now I'm going to show you how to launch that, and we can view this scene that we trained. So now if I go back to my command prompt, we need to get into that folder where the exe is to make things easy on you. I'm just going to change directory to viewers/bin. Like so. And now I'm in that bin folder where it is. And if I start typing SIBR, because that's the name of the viewer, and hit tab a bunch of times, you'll get to the point where it has the exe. And then we're going to go space-m. And if you want to know what that looks like, it's this. You're going to go to the cber install directory, bin, the app. That's what we just found. And then you're going to put in here we go, the M, path to the train model. So path to train model was in the output folder. So if I go back to your output folder, it was this J Weatherford. And I'm just going to take the top level there. Enter. And now it'll launch the viewer. Takes just a second for it to load. And here we go. We'll watch it in real time. You can resize this window, but you can't change the aspect ratio right now. I don't know if that's actually even possible. But I have my real-time viewer going. And you can move around with the WAS keys. They have instructions on the project page on how to do it. That was like forward, backward, left, right, up, down. And then it's J and L are your like pivot. I and K are your vertical pivot. U and O, I don't know. As I move around, there's different buttons to pivot in different ways. I can change how I view it to trackball. So I can do kind of your drag and pivot, right, left click. You can translate and rotate, move around the scene. And you notice if you get really far off where the cameras are taken, things get kind of terrible. So think about that. If you're captured from inside the scene, it'll look great. But anytime you get too far out, things start to fall apart. You can also in here, so you can change like the way you view. This interpolation one will just kind of like move its way through all of your key points from your cameras, which is kind of cool. And then you can, you can snap to specific key points. So if I said I want key point 150, it'll put me right to 150, and you can step through them. You can change your field of view, things like that. And then I have not going to have in this video, but you can basically record your movement. And then you can, when it's done, you can just export that video. It's a little confusing. I figure most of you guys will figure out this viewer by just clicking around. A couple things I want to note, if you go to the top here and you have, let's say, a 4K or a high-res screen, and you go to your display and turn off HIDPI, you get bigger controls. Also, if you go to and turn off VSync, you'll get the full frame rate. So I'm 160 frames per second. So that's pretty nice. And with your WAS keys, if you don't find it's fast enough, this acceleration will speed that up. So if I make it like 2, now I move much faster around the scene. So just keep that in mind as well if you get kind of like crazy by how slow it is. So there you go. This is rendering splats. You can change the size. So again, like we're just looking at a bunch of these overlapping splat shapes. And when they're full size, it just makes up the scene. You can crop the scene. This stuff you should probably figure out pretty quickly on your own. But let's see, I can just like crop it down to just me, just by dragging these. Like so. And now I just have myself, which is pretty cool as well. So if I go to trackball, it just have me, and it looks like I haven't fully cropped it down. But you can do all kinds of things like that. You can go capture. You can export things. There is one other, a couple of more views as well at the top here. You can let your initial points. This is your sparse point cloud. I can get into how this all works later and explain it. And then ellipsoids. So ellipsoids are like the splats in their full scene, rendering everything. You'll notice you get way less, your metrics go way down. That's because it's trying to render everything as opposed to just interactively what's in your view. Let's go back to splats. You'll notice it goes way back up. Look at that. I'm at 500 frames per second. And then there's this one other crazy top view as well, where it shows all your your camera positions, things like that. I think could be helpful if you know what you're looking at. It's just hard to navigate, but you can see your active camera as well as you move around the scene, what you're looking at. And so that's it. That's how you get this running. Again, if you have questions, I highly suggest that you ask them in the video notes and also ask them in the GitHub repo if they're really technical. But you should be up and running with this. If you just take photos, you can skip the whole FFmpeg. I'll make sure that's in the GitHub repo, how to prepare images for that as well. And then you're off to the races. I hope you found this video informative. I will do an advanced tips video soon, where we'll go into some more of capture techniques and things, but this should be enough just to get you up and running and having some fun. So if you make a splat, please, please, please share it with me. I'll also put my Twitter and LinkedIn handles at the end of this. If you see that, just go ahead and just at me, and I would love to reshare these. And then also follow this channel, because I will be putting out a lot more content around nerfs and 3D Gaussian splatting coming soon. So I'll see you in the next video.